Hi there, Merry Christmas, and welcome back to the Ephemeris podcast. I'm your host, Aphelion, and it is nice to be back. I know the last two, or this episode and the last one, will be coming in quick succession because I did publish um, the what was supposed to be a midweek episode on Friday. And yes, this will be coming out on Sunday as usual, as I tried to get it to be published on Sunday. So yeah, um, hopefully you're enjoying the back-to-back content if you're keeping up with the episodes. And yeah, so today's episode will be on Carl Sagan, and it's a bit of a different direction compared to some of the other astronomers we have looked at because we have primarily focused on astronomers who are focusing mainly on like universal systems and celestial objects and what they mean in the grand scheme of things. But with this episode, we're going to look a little bit more into planetary science. So, yeah, we're going to aim to summarize Sagan's work very briefly and his significance a little bit. So, let's start out with the biography section of the episode. Carl Sagan was born in Brooklyn on November 9th, 1934. He developed a scientific curiosity early on in his life from exposure to science, which his parents helped him with despite them not having science backgrounds. Sagan took lots of trips to exhibits, museums, planetariums, all that kind of stuff, and also regular trips to the library to get some sci-fi books and further his fascination with the universe. It wasn't like solely sci-fi books because there's a story about how he learned that all the stars in the universe are their own kind of suns, and that was a sort of key moment for him. But anyways, Sagan had excellent grades in high school, and he built his own laboratory to investigate molecules in chemistry because he felt like his courses in public school were not challenging him enough, or so is said. He went to the University of Chicago at the age of 16, and he did his honors graduate research on the origins of life. He earned a Bachelor of Science in Physics in 1955, Master of Science in Physics in 1956, and a Doctor of Philosophy in 1960. And his PhD dissertation was on planetary studies and planetary science. As for his career, Sagan's first job afterwards was on a classified military project, so quite a quick turnaround right there. And it was actually about detonating a nuclear bomb on the moon to see its effects, which, yeah, I guess that just speaks for itself. It kind of tells you about the time period we were in as a country, the United States, and yeah. It was only a while before Sagan began working at UC Berkeley as a fellow and writing about Venus's atmosphere. And then he was given a assistant professor position at Harvard before being accepted for tenure at Cornell University because, in fact, he was rejected of a tenure for a tenure position at Harvard. There are some speculations about that stuff, but I'm not going to get too deep into it. It's the biography section. Yeah, so that's at Cornell University is where Sagan would be for the next 30 or so years. And, we can't forget about the fact that he was an advisor for NASA on a ton of robotic spacecraft missions. And then he also helped out with the moon landing, talking to the astronauts who were going up on that mission. So yeah, that is enough about Carl Sagan's biographical history. Let's get into some of his super duper important work here. So the first thing that he did was on Venus, as I had referred to in the biography section. Before Sagan's work, we weren't very aware of what exactly was happening on Venus's surface. There were a lot of theories, which Sagan had many of. But his preferred one was that Venus was extremely hot, and he, speculated the temperature to be like, I don't know, 500 degrees Celsius, or like, hotter than 500 degrees Celsius based on, measurements from Venus's atmosphere. And Sagan also contributed to the Mariner 2 mission that would confirm his theories. And so it was the first flyby of Venus, the Mariner mission, and it returned data successfully. And on top of getting temperature measurements, Mariner 2 went to Venus to measure the interplanetary magnetic field. And that refers to the changes in the magnetic field around the sun carried out by solar wind flows. And, with the sun itself having a rotating magnetic field, and then the dynamic pressure caused by solar winds, a lot of goofy stuff happens with magnetic fields in our solar system. So IMF is just one of those things. So yeah, that's besides the point. Just know, Mariner 2 mission confirmed some of Sagan's theories because, he was like, oh, it's going to be extremely hot because we know that the atmosphere is quite hot, like 500 degrees Celsius. So, some of the next investigations by Sagan were into Titan, which is a moon of Saturn, and Europa, which is one of Jupiter's moons. And these ideas had some merit as well. The predictions about these two moons were based on the presence of water on these moons and astrobiology in general. And what Sagan theorized was that both moons possessed oceans of liquids, and Europa might particularly have water. Very fortunately, Galileo gave us answers as to whether this Europa theory was true, and it proved the theory in a way by giving evidence that liquid oceans do exist under Europa's icy surface. In addition to this, it also discovered a lot about Io's volcanic activity and complex plasma interactions, so to speak. And it discovered Ganymede's magnetic field. There is also evidence that Europa, Ganymede, and Callisto have a liquid saltwater layer. So that's a lot of stuff that Galileo did. It's kind of nice to get into some of these planetary missions because it is a part of space science and astronomy today, and the missions that were out there at the time. Very helpful for understanding our cosmic backyard. For Titan, the major observation that was made about it was its reddish haze containing complex organic molecules that rained onto Titan's surface. So maybe some evidence to point towards an ocean layer that Titan might have. But yeah, all interesting stuff. Other than these two sections of study, the moons and Venus, Sagan had some important predictions about Jupiter and Mars. He speculated that Jupiter's atmosphere has life, and he went against this idea that Mars's color changes because of the seasons that it has. And in fact, he theorized that it was because of windstorms rather than seasonal changes. Sagan also helped decide the landing spots for the Viking missions to Mars, which transmitted the first photos of Mars from the surface. So yeah, that is basically the meat and potatoes of Carl Sagan's work, which are in the interest of the season's focus. Obviously, the bulk of the significant work that Carl Sagan did was, hosting the show Cosmos and being a science communicator, a political advocate at times, with testifying to Congress about the effects of, nuclear warfare and some other events that were going on in the 1980s. But mainly it was Carl Sagan having notoriety for, hosting Cosmos. Some other things. Sagan received the Pulitzer Prize for The Dragons of Eden, which, despite the title, is nonfiction. And another notable work of Sagan's was titled Pale Blue Dot, A Vision of the Human Future in Space, which is published in 1994. And in this work, Carl Sagan discusses humans' place in the universe and the future. Yeah, so before I leave off this episode, I do want to mention a lesser known fact about Carl Sagan, and it relates a little bit to what we've talked about this season. So, what the fact is that Sagan was a critic of Plato's work. He believed Plato's philosophy about understanding the universe was contradictory to true scientific discovery, and he thought Plato was hyper focused on ideas and not the truth behind how the universe works. Yeah, so I think the quote goes something like, he believes that ideas are more worth than the natural world, and he's just focused on observing the universe and not figuring out, what's really going on. So, yeah, lastly, just something I want to mention really quickly. The Center for the Study of Life in the Cosmos was honored in Sagan's name on November 9th, 2001. So, yeah, that's all I gotta say about Carl Sagan. Hopefully, you all enjoyed this episode of the Ephemeris podcast. If you're new to this channel, thank you for joining me today and making it all the way to the end. I would sincerely appreciate a subscribe on YouTube if that's where you're listening, or a follow on Spotify will suffice. And yeah, if you are a returning viewer and you've been watching for a while and you'd like to share the content, go ahead. I would appreciate it. Get more exposure on this channel. And until the next episode, where I believe we will be looking into Stephen Hawking, I will see you all later. Peace.